All right, Mr. Emmett here. Goal for today is to solve right triangles. And in this process, we're actually going to introduce finding missing angles using sine, cosine, and tangent. In order to find a missing angle, what we're going to do is we are going to use the inverse. Okay? So, fortunately for us, we don't have to pull out a chart like they did in the old days. Our calculators will do the inverse for us. So when I look at my calculator, above the sine, the cosine, and the tangent button, you see a sine minus 1. That means inverse sine. Cosine minus 1 means inverse cosine, and tangent minus 1 means inverse tangent. For us to use those, we have to press the second button first so that it pops up. We also need to, again, make sure we're in degree mode. Notice mine says degree right here. I know I'm in the correct mode. And I can use that button in order to find some missing angles. It's not going to be uncommon to get decimals. So, in this process, if I'm finding an angle, so if the tangent of angle A is equal to x, then the inverse tangent of x, whatever this value is going to give me the measure of angle A. So if I'm finding a missing angle, I use the inverse. All right, so we're just going to practice using our calculators to find this first. So in this problem, A, B, and C are acute angles inside of a right triangle, and we're going to use a calculator to approximate the measures of A, B, and C to the nearest tenth. So I'll round to the 10th. So in order to do this, the tangent of A is equal to 0.75. So for me to find angle A, the measure of angle A is equal to the inverse tangent of 0.75. So I'll just have to type that into my calculator. I need to use the second button, tangent inverse of 0.75. Press enter, and I get 36.86. So that's 36.9 degrees. All right, this time sine of angle B is 0.87, so I'm going to use inverse sine. Measure angle B equals inverse sine of 0.87. So I need to type that into my calculator. All right, so second sine, finding an angle, need to use the inverse, 0.87. Press enter, and I get 60.45, so that's 60.5 degrees. So we're pretty fortunate to have the calculators that do this for us. And the last one, this time says cosine C is 0.15. So to find angle C, we're finding an angle. If I find an angle, I have to use the inverse. So inverse cosine of 0.15. So second cosine, 0.15. Enter. And I get 81.37, so the measure of angle C is 81.4 degrees, okay? So, excuse me. Our next example says determine which of the two acute angles has the given trigonometric ratio. So it says the sine of the angle is 12 over 13. So if it's sine, it's opposite over hypotenuse. So for us to be opposite of the 12, I would have to be at angle E. Angle E is opposite of 12 over 13, so I'm looking at angle E. This one says the tangent of the angle is 5 over 12. So tangent is opposite over adjacent. So I need to be opposite of 5, so that would put me at angle F. All right. To solve a right triangle, in order for us to solve a right triangle, I'm going to find all the missing parts. Okay, if I'm solving a right triangle, I'm going to find all of the missing parts. Therefore, I need to find 6 things, 3 sides and 3 angles. In order to do that, I'm going to have to know 3 things. I'm going to have to know 2 side lengths, or 1 side length, and an angle. Okay, and one of those angles is obviously the acute angle. So, in this diagram, let's see what we got. I'm going to label everything I have to find. Okay, now notice how this is using little letters. This is fairly common when we work with triangles. The side little c is opposite angle C. So side little b would be opposite of angle B. That's kind of where they got the C from. I'm actually going to label these out and say what I'm finding. So my 3 sides are BC. I know that's 3. I know CA is 2, and I have to find BA. So for me to find BA, I'm going to go back old school. if I know two sides, I can use the Pythagorean theorem to find the third. So hypotenuse, so c squared in this case is equal to 3 squared plus 2 squared. Now I need to solve this, so c squared is equal to 9 plus 4, which is 13. It says to round to the 10th, so I'm going to take the square root of both sides, and the square root of 13 is approximately 3.6. All right, so got all the sides. Now the angles. Angle C is equal to 90. Measure angle B, we don't know, and we also do not know the measure of angle A. So I'm going to find angle B first. So here's angle B. The two sides that I have whole numbers for are 2 and 3, so I want to use whole numbers. So this is opposite, this is connected to it, it is adjacent. The ratio with opposite and adjacent is tangent. So the tangent of the angle, it's B, we don't know it, is equal to 2 over 3. So when I find the missing angle, I have to use the inverse. So the measure of angle B is equal to the inverse tangent of 2 over 3. Now, for me to type that into my calculator, again, I'm finding the angle, so I use the inverse. Just put 2 divided by 3 and close the parentheses. That's the fraction. And we get 33.69, so that's 33.7. And then for us to find the third angle, all three have to add up to 180, so 180 minus 90 minus 33.7 gives me 56.3 degrees. I have solved the triangle. I found all three sides and all three angles. Okay? So, the next example says to solve the right triangle. All right? In this diagram, I'm just going to put all my values into the picture. So the first thing I have to find is DE, so we'll call this piece little f. That is the hypotenuse. Since I know two sides, I'm going to use Pythagorean's theorem to find the third. So 20 squared plus 21 squared is equal to f squared. So 20 squared plus 21 squared, 841. Take the square root, and we're supposed to round to the 10th, so just need a decimal. Square root of 841 is, oh, it's actually a whole number, it's 29. That was a Pythagorean triple. So DF is 29, I put that in. Or sorry, DE, side F. All right, now some angles. Let's find angle E. There's my reference angle. Let's use opposite and hypotenuse. You have choices on this one. You could use any. I'm going to use O and H, opposite and hypotenuse. So sine of the angle, angle E, we don't know it, is equal to opposite 20 over the hypotenuse 29. When I'm finding a missing angle, I have to use the inverse. So the measure of angle E is equal to the inverse sine of, I put two n's, 20 over 29. Have to use a calculator for that. Put that where you can see. 20 divide 29, and we get 43.6. And then to find the last angle, we'll subtract from 180. So 180 minus 90 minus 43.6, 46.4. So I put all my values in the picture, okay? All right, next one. This time I'm gonna label everything out. I have to find everything. So my three sides, HG is equal to 109. HJ is equal to 91. GJ is the first thing we have to find. So opposite angle H, that would be side little h. That is not the hypotenuse. The hypotenuse is 109. So we would use Pythagorean's theorem and say 109 squared equals h squared plus 91 squared. Now I'm going to use my calculator to solve this, okay? So for me to solve it, I have to take 109 squared minus 91 squared, because I'm bringing the 91 over. And then I can take the square root of that, because I already subtracted. So 3600 is equal to h squared. Take the square root. I'm using second answer. I get 60. So this side is 60. We had another Pythagorean triple. All right, now the angles. Angle J. Was 90. I'm going to switch colors here. Measure angle H. And we also have to find the measure of angle G. All right, so we'll find H first. So from the H, let's use opposite and adjacent. So that would be tangent. So the tangent of angle H equals opposite. Ooh, what am I doing? H, sorry, I gotta backtrack here. Opposite, adjacent. 91 is connected. So opposite is across, adjacent is here. So the tangent of H equals 60 over 91. When we're finding the angle, we have to use the inverse. So inverse tangent of 60 divided 91 is 33.4. And then to find the third, we just have to subtract. So 180 minus 90 minus 33.4, 56.6 degrees. We found all of them. All right, so that's solving the right triangle. And let's see here. We got just a couple left. Okay, so solve the right triangle. Again, I'm going to label out everything I have to find. All right, HJ. Don't know it. HG. 13. JG. Don't know it. Now the angles. Measure angle H equals 25. Measure angle J is 90. And the measure of angle G, I'm going to find that first. Since I know the 2, I just have to subtract from 180. 180 minus 90 minus 25 is 65 degrees. We found that first. Now the sides. We're going to use H as our reference angle. Let's find this piece first. It is opposite hypotenuse. Ratio opposite and hypotenuse is sine, so we'll use the sine. So the sine of 25 equals, opposite is little h over the hypotenuse 13. Put it over 1 and we will cross multiply to solve. And we get 13 times the sine of 25. So h is equal to 5.5. So h was jg, so that's 5.5. All right, now we have to find the other one, little g. We're still going to use the same reference angle. That is adjacent and the hypotenuse. We want to use the whole number. We're going to use that 13. So adjacent and hypotenuse, cosine of the angle 25 equals the adjacent piece, little g, over the hypotenuse 13. Put it over 1. And we can cross multiply to solve. All right, so 13 times the cosine of 25. 11.8. And little g was side HJ, so that's 11.8. And we got it. So, solving the right triangle, you have to find all the missing parts. 6 total things. So, our next example here says your school is building a rake stage. The stage is 30 feet long, so from here to here is 30. It has a total rise of 2 feet. And you want the rake angle of elevation, so this is the angle of elevation looking up, to be less than 5 degrees. So we have to check that. So from this angle, that's our reference angle. 2 is opposite, 30 is the hypotenuse. Sine of the angle, we don't know it, that's x, equals opposite 2 over hypotenuse 30. If we are finding the angle, we have to use the inverse. So x is equal to inverse sine of 2 divided by 30. We have to see if that's less than 5. And we got 3.8. So since x is 3.8, is it within the desired range? Yes. it is less than 5 degrees. Okay. So for these next two, these are a U try. Let's see here. Number 8 is to solve this here. So do that first. Number 9 goes with here. This wasn't really printed off extremely well. So I'm going to do number 9 first. Okay, number 9 says, in example 5, suppose another raked stage is built that has a total length of 20. So in this case, my diagram looks something like this. The stage is now 20 feet. We're looking for the angle of elevation X with a height of 2. We have to see if that's within the desired range. So again, opposite hypotenuse. Have to use sine. Sine of the angle is X equals, well, that's my O. Opposite, 2 over the hypotenuse, 20. When I'm finding the angle, I have to use the inverse. So X is equal to inverse sine of 2 over 20. And I got 5.7. So not within range. Too steep. It's more than 5 degrees. Okay. And the last one, solving the triangle. I'm going to do this one in the diagram again. Okay. So I know this angle is 52. I find the missing one first. All three add up to 180. So 180 minus 90 minus 52 is 38 degrees. So I found the first missing angle. Now the missing sides. We'll call this little z and this little x. So the angle we know is here, 52. Let's find x first. Opposite adjacent. TOA. Opposite adjacent is tangent of the angle. 52 equals opposite x over adjacent 8.5. Put it over 1 and we'll cross multiply to solve. So 8.5 times the tangent 52 is 10.9. So x is 10.9. And lastly, z. We'll still use the 8.5, adjacent and hypotenuse. Cosine of the angle, 52, equals the adjacent piece, 8.5, over the hypotenuse, little z. Put over 1, have to cross multiply to solve. Z is going to go across, 8.5 is over here, so we're going to have to divide. 8.5 divided by cosine 52 is 13.8. And we found all the missing pieces. All right, that's it for chapter 9. Have a good one.